In section 8.5, we're starting to talk about probability distributions and expected value. In order to have something like an expected value, I'm first going to introduce what's called a random variable. And a random variable is just something that we take and we assign a number to each outcome of an experiment. So in the cases of a binomial experiment, we're actually talking about the random variable being the number of successes. So that's something where we've already seen a random variable. We're saying, okay, if we get 3 successes, then the number that's assigned is just the number 3. Now, it doesn't always come quite as naturally to have a number that's assigned to an outcome. Sometimes you have to be a little bit more, creative with it, but usually it's not bad. All right, so the probability distribution, this is just what we, when we're talking about the probability distribution of an experiment, this is just all of the different outcomes, well, in this case, all the different values of the random variable and the associated probability. It's just listing out all of the different things that could happen and their probabilities. And a histogram is what we get when we take and we graph that. It's a bar chart that displays the information of the probability distribution. Alright, so the expected value, I'll do some examples of these. I'm just introducing what these words mean first. The expected value is an average. So the average number of a random variable weighted by the associated probabilities. That's what it says here. So let's say, say you're flipping a coin and you assign a value of, let's say, tails is a value of 1 and heads is a value of 0. And the number of successes, actually let's just say the number of successes. This is going to be our random variable. If you flip the coin 10 times, then most people have an intuition here. You would expect to find approximately 5 heads. Now, this idea of expected value, what it's doing is it's saying, well, this sometimes we'll get more heads, sometimes we'll get fewer heads, but on average, if we were to run this experiment a bunch of different times, one time I flip 4 times, next time I get 6, the next time I get 5, the next time I get 5, the next time I get 5, the next time I get 3, the next time I get 3 again, then 5 and 5. And if I was to run this experiment enough times and average those numbers together, this would come out to an average of 5. We would expect to get 5 heads here. Because you can actually kind of see that through symmetry. If you're just as likely to get 5 heads as you are to get 5 tails. Now, the actual way we compute this is we go through and we say, okay, x1 is, so this would be the probability. If we're flipping the coin 10 times, then x1 might be, this is the getting 0 heads times the probability of 0 heads. Plus 1 head. This is what this one would be. The probability of getting exactly 1 head times the probability of that x equals 1. Plus 2 times the probability that x equals 2, and so on. And we'd go all the way through plus 10 times the probability that x equals 10. And since we're doing this, it should remind you of kind of like an average. Each of these is a probability, so these end up being kind of like, well, these are weights. We're adding up 0 with a particular probability, 1 with a particular probability, 2, and all the way up through 10 with their probabilities. And in this instance, this would come out to be exactly 5. Now, this is actually a special case of an expected value. Special case expected values in a binomial distribution. We can actually just do n times p, and this is the kind of shortcut that comes naturally to a lot of people here. N is the number of trials. This would be 10 trials. The probability of a success is 0.5. N times p is 5. So that's another way of getting this. And seeing as how flipping coins and counting the number of heads that comes up is binomial, this is by far a much easier way to do this particular question. But a lot of these expected value questions will not be binomial, and we'll have to do this, this other formula. All right, so a fair game. We call a game fair when the expected value is 0. So typically when we're talking about playing a game, if you win money, that might be a positive value. If you lose money, that would be a negative value. If you play a fair game, then if you were to play this game over and over again, you would expect overall to lose $0. That's what we're calling a fair game. But you would also win $0.